Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review what was covered in week 8. So we looked at quantiles, or the inverse normal distribution. We're actually doing the opposite of what we've been doing previously. So previously I'd give you a normal distribution, tell you the mean and variance, and I'd give you a score, like I'd tell you this value here, and you had to find the area up below or above it. You had to find the probability of being less than or greater than that score. We're actually doing the opposite this week. What happens is I will give you the area or probability that's less than or greater than a score, and you have to tell me what the score is. So if I said calculate the first quartile if x is normally distributed with mean 25 and variance 25, what we want to find is the value that goes here so that 25% of scores are below it and 75% are above. That's what first quartile means. 25% of scores are below it. So obviously this number is going to be less than 25. Now to do this, we just use our graphics calculator. Because we're doing the opposite or the inverse of what we've been doing with the normal distribution, use the inverse normal function in your distribution menu. Press second and vars, and this should be the third option in the distribution menu. So you input in the probability you're given, the mean, and the standard deviation. So if the variance is 25, standard deviation is root 25, which is 5, and then you put in left, right, or center. So we put in left here because the 25% that I was told in the question is to the left of the value we're interested in. So putting this in my calculator, I get 21.63. So this score here is 21.63, 25% of scores are below it. So in the second one, we're going to calculate z such the probability of being greater than z is 2%. So note, whenever we're talking z, we're talking the z distribution or the standard normal distribution. That has mean 0, standard deviation 1. So in this case, I want to find this value here so that 2% of scores are above it, or in other words, the area to the right of it is 0.02. So I put in the value for the probability that I was given, mean, standard deviation. This time I put right because it's the area to the right of the value I'm interested in. So putting that in our calculator, we'll get 2.05. So that means in any normal distribution, 2% of the scores are more than 2.05 standard deviations above the mean. Sometimes you'll get a question like this. The probability that x is between 30 minus k and 30 plus k is 40%, and we're told x is normally distributed, mean is 30, standard deviation is 10. So this is what we're finding here. We want to find a value k so that the area in this central part is 40%. So when we use the inverse normal function, we use center because we're calculating the area in the center. So we put in the probability 0.4, the mean and standard deviation, and center. So the calculator returns with something that looks like this, 2 numbers. So what that's saying is that 40% of scores are between 24.76 and 35.24. So that means that k is just the distance from 30 up to here. K is just 5.24. So this is made really easy by your graphics calculator. We're using inverse normal because we're doing the inverse or the opposite of what we were doing previously. All right, let's look now at a worded problem. So let's look at this question. Company notes the length of the life of their batteries. Battery life normally distributed, mean 60, variance 64, so standard deviation is 8, and we're told the top 2%, bottom 5% of batteries are rejected. What is the range of acceptable battery lives? So a company might reject the bottom 5% because they don't last long enough and customers will complain. Maybe they'll reject the top 2% because if the batteries last too long, then the customers might expect that the next time they purchase. So what we're really told here is we have a normal distribution, mean 60. We want to find the value A so that there are 5% of scores below it, and the value B so there are 2% of scores above it. And this green area is the acceptable range. So we just use inverse normal functions. So for A, we input probability, mean, standard deviation, and left, because we're told 5% of the area is to the left of A, and that gives us 46.8. And for B, very similar, but it's to the right. We want 2% of scores to be to the right of B. We get 76.4. So the range of acceptable expectable battery lives for these company, 46.8 hours to 76.4 hours. All right, let's look now at a question where we're finding the variance. So in this question, we're told the time students take to get to school, normally distributed, mean 20, and we're also told 1.3% of students take longer than an hour to get to school, and we're asked to find the variance. So note, whenever you're asked to find the mean or variance, you always use z-scores. So this is what the question told us. We have a normal distribution, mean 20, and 1.3% of scores are above 60. Now, if we want to know the variance, what we do is we use z-scores, because what we want to find out is this score 60. Is it 2 standard deviations above the mean? Is it 3 standard deviations above the mean? That's why we're using a z distribution. We're finding what's the corresponding z value so that 1.3% of scores are above that value. So we use inverse normal. This is the probability, 1.3%, mean and standard deviation of a standard normal distribution. In this question, we use right because we're told 1.3% of scores are above, or in other words, the area to the right of this value is 0.013. The answer our calculator gives us is 2.226, so on. What that means is, in any normal distribution, the point at which there are 1.3% of scores above is 2.226 standard deviations above the mean. This score 60 must be 2.226 standard deviations above the mean. So now we're just going to use the formula for z-score. So basically what we found is that the score minus the mean over the standard deviation, which we don't know, that's equal to 2.226. This is z-score of the score 60. So we can easily find what sigma is. So on top, we just have 40. So 40 over sigma equals this. We can just move the 40 and the fraction line over. So we can just go 40 over 2.226, which is sigma, and we get about 17.96. So that's how we find the standard deviation. Of course, the variance is just that number squared. So even though I've rounded it here, you should use exact values on your calculator. When you're doing this step, you just go 40 divided by answer equals that, and then you go answer squared, and you should get about 322.84. That is the variance, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.